Yeah, hello everyone.
Hello.
Hello.
Yeah, okay. Let me unmute. Okay. Okay. Please please unmute. Unmute yourself over there. Yeah. I'm a mature unmute. Okay. Yeah. Hope you all are fine.
Yes, sir.
All right.
Yes, sir.
Yes, sir. Yes, sir.
Yes, please. Okay. So we'll be treating a topic called magnetism. That's where we are before the pandemic came up. So we'll be continuing with magnetism today. Hope you all can see the slide on your screen.
Yes, sir.
Okay. So now I'm coming to mute all of you and the lesson will begin.
Okay. Okay.
Okay.
All right.
If you say so.
Okay, so we'll begin with the definition of a magnet. Who who has an idea about what a magnetism is? If you have any idea, you can raise up your hand. Then we'll see from there. Who has an idea what magnetism is? If you have any idea about it, then you just raise up your hand. Let me see. Please show, yeah. Okay. Okay, to start with, the first slide is what's a magnet? And you all know that a magnet has what poles, and a magnet is a substance that attracts and what and repels. It has this property on its poles, yeah. So due to the properties of the magnet, we can use the property to help define what a magnetism is. Okay, Kudoda, please can you tell me what you know or what an idea you have about magnetism? Just give me an idea about it, let me know.
Magnetism is the process whereby a magnet attracts or repels a uh, material.
Okay, well said. Okay, can I please mute yourself? Let me go to Sedinam. Sedinam, please, can you also help me? Do you have any idea about a magnet? Hello, Sedinam. Hello, Sedinam.
Hello, sir.
Yeah, can you please tell the house what a magnet is? The idea I have about a magnet.
Sir, magnet
Say a magnet is a material that attracts objects.
That attracts hot objects. So you
That
are all
attracts metallic objects.
metallic objects. Okay. So you are all basing your definition of hot attraction and hot repulsion. Okay. That means these two things are all properties of what a magnet. Uh-huh. So a magnet has what the power to attract or repel based on the parts what being brought together. As you can see on your screen, a magnet is defined as a piece of what? A magnet is defined as a piece of a metal which has the property to attract certain hot materials. And the materials are listed below. An example is what a bar magnet, the cylindrical magnet, and hot the ring magnet. Why these names? The bar magnet, cylindrical magnet, and hot the ring magnet. These names are given to them because of what their structure. The cylindrical magnet is cylindrical in shape. The ring magnet is hot in the form of what a ring, and the bar magnet is also in the form of what a rectangular shape. That's why these names have been given to them. Please, do you understand what I'm saying? Hello?
Yeah, we understand.
Okay. Okay, now we move to. Okay, Bisa, I saw your hand. I'll let you in right now. We are moving to the pose of a magnet. Pole supreme means what the two ends of what a magnet. Thus, we have two main parts of the magnet that are called the poles. That we have the north pole and what the south pole. These poles are the part of the magnet where the force of attraction is great. You know, a magnet cannot attract at the middle. It attracts itself at the poles. That's the north, the extreme ends of the magnet. If you take a bag magnet, for example, um, let me use this. Please, can you all see? Hello?
Yeah.
Can you all see what I'm holding?
Yes.
Okay. Okay. So, for example, if this is my magnet, the poles are the extreme end. That's this end and hot, the other end. If here is the north
Yeah.
pole, here will become hot, the south pole.
The South Pole.
But the middle is not having any pole over there. The extreme ends are hot, the poles of hot, a magnet. And these ends are the parts where hot, the force of attraction is hot, great. So
Great.
there's no force of attraction hot at the middle. There's force of attraction at the hot extreme ends of hot, the magnet. When this is the north pole, it gets attracted to hot another magnet which is having hot a south pole end. Okay. Okay. Bisa, please you can ask your question. Unmute yourself and.
Steph, I didn't want to ask a question. Oh. I couldn't see the slide. That was why.
Oh, okay. Okay.
All right.
Okay. So when you bring an ion filing near a bar magnet, they arrange themselves at the ends of what the bar magnet, which are called the poles. So the force of attraction occurs at what the poles of the magnet. That's the north pole and the south pole. So when you bring an ion filing right now, let's say this is our magnet, where the attraction is going to occur is either the north pole or what the south pole. Do you get it? Do you get it?
Yes,
Hello?
sir.
Yeah. And at the extreme end, a straight line drawn through what the poles is called what the magnetic axis. Okay. So if you take the north and the south pole, basically, if you draw a straight line through the poles of the magnet, that's the north and the south pole, that straight line that passes through the two, we call it what the magnetic what axis. And the distance, the length between the north and the south, we call it what the magnetic length. And we have different types of magnets. We have the natural, the artificial, the temporal, and the permanent magnet. As the name implies, natural, that means it occurs in nature. It occurs in nature. It's not man-made. No, it occurs in nature. An example of that is the earth and the magnetite. And we move on to the artificial magnet. Artificial magnet is a man-made magnet. That's they are made in their laboratory. For example, is an electromagnet. Electromagnet simply means using electricity to induce magnetism into a magnetic material. So an example of the artificial magnets is the electromagnet. Okay, and we have the temporal magnet also. This is a magnet which keeps its magnetic strength for a very short period of time. That means they cannot keep it for a very long time. Okay, so if you take a solenoid, for example, a solenoid is a piece of metal with a wire wound around it. So when a current is passing through a metallic substance, what happens is that it induces magnetism, or it induces magnetic flux into that substance. So for example, when let's say this my metallic substance, that's the nail, then a piece of wire wound around it. What happens is that when you pass current through this, what's going to happen? There's going to be a magnetism induced in the wires. And these wires, when magnetism is induced, is going to transfer those magnetism into this metallic substance, which is the nail. So anytime you have current passing through a metallic substance, it induces magnetism into that substance. And that magnetism is a temporal. It's temporal. For some time to lose its magnetism. Temporal means it cannot attain its magnetism for a very long period of time. After a short period of time, it loses its magnetism. And we have one to we call the permanent magnet. The permanent magnet is a magnet which keeps its magnetic strength for a very long time. An example is the one we use in the laboratory. Those are the ones we have in our the speakers. If you look at the back of your speaker, there is a magnet there. Fridges there are magnets on the fridge doors. Yeah, because without a magnet on your freezer doors, what's going to happen? When you close it, it's not going to close firm. It will still open. So the magnetism over there helps your freezer doors to lock without any hindrances. Okay, so we are going to continue with the slide. Can someone tell me the uses of a magnet? Some of the uses of a magnet in our everyday life. We use magnet in our various homes. You can raise up your hand, let me call you, then you give me one of the uses of a magnet. Maybe your mom is a tailor, you use a magnet for certain things in the house. Yeah, you just raise up your hand and tell me what are some of the uses of a magnet that you've witnessed so far. um I'll call Bisa. Bisa, unmute yourself. Bisa. Hello. Okay, then Awaga. Awaga.
Sir,
Yeah, tell me
the magnet is used.
the
A
use
magnet is used to gather nails.
to gather nails.
Like let's say pins, sorry, pins, safety pins, and those pins. Those are the tailors use.
Okay. Um, I'm a mature.
Sir,
Yeah. Give me one use of a magnet.
they are used for lifting heavy materials at harbors.
At harbors.
Yeah, like those big containers.
Okay. Okay. So the cranes, all those things, they have a magnetic substance, right? That means
Yes, please.
okay. Okay. Is Precious there? Precious.
Say,
Yeah. Tell me one use of a
they
magnet.
are used in memory devices for computer.
They are using what? Memory devices.
Say they are used, yes, of
Okay.
computers to store data.
Okay. That's good. So they are using memory devices that's in the computer to what? Store data. That's one use also. Yeah. Okay. All right. So we'll continue. All these things we are doing, we are just looking at some brief definitions, the types, the uses, all those things. We will be moving into calculation very soon, but today we are not going to do calculation under the magnetism. Next time when we meet, make sure you bring your this thing, your particulars. That's the calculator, everything. Let everything be available for calculation next time. So we'll continue with what the slide. Hope you are making your notes. So I have an assignment under give 10 uses of what a magnet. I will inspect that when we meet next time. That will be next week. And I've listed some of the uses over here. They are used in loudspeakers, electric motors, and hot generators. Electric motors. For the motor to turn, hot it uses hot a magnetic field. Thus, they use electricity to hot generate hot a magnetic field, which turns the coils. The motor is having the rotor and hot the stator. The rotor is the hot the rotating part. The stator is hot the stationary part. For the rotating part to rotate, for example, when you go to the market where they used to sharpen cutlasses and things, the place that used to turn, we call that place or the rotor. For it to turn very well is on the mechanism of what magnetism. Is based on the mechanism of what magnetism. And opposite of a motor is what a generator. So if magnetism is used to what generate what magnetic flux, which helps the rotor to what rotate. Hello, who is raising up his hand over there? Okay, let's continue. So if magnetic flux is what generated, which helps what the rotor to what rotate, it also helps what whilst opposite of what the motor is what the generator. That means what magnetism is also what required in hot generators. Okay, it's also used in hot computer memory devices to store data, as Marina said. Yeah, it's also used in hot manufacturing of hot freezer doors, as we all have in hot our various homes. Yeah, you realize that sometimes if you just leave your freezer door, it closes on its own. You don't have to hot apply any pressure again. Okay, we'll be moving to magnetic materials. Why the name magnetic materials? You know, for you to, let's say, prepare a diet in the house based on what maybe, let's say, you want the taste to be, how you want the taste to be depends on what the ingredients what you use. Similarly, if you come to magnetic materials also, the materials that what the magnet is what being made of determines what how strong the magnet what will also be. An example over there, we have the types over there. That's what the ferromagnetic hot materials. Ferromagnetic material. We have what the die hot magnetic hot materials. And we have what the soft magnetic materials and what the hard magnetic hot materials. Okay. So I'll pause here and call Dr. Furu Joyce. Please unmute yourself and tell us what you know about hot ferromagnetic material. Maybe you might have come across it. Any idea about it? So that I tell the house. Dr. Fu.
Yeah,
Yeah. You have any idea about ferromagnetic materials?
I'll try.
Okay. Yeah, so tell the house.
Ferromagnetic, ferromagnetic materials are materials that can be attracted by magnets.
Okay, all these materials you are seeing here can be attracted by a magnet, but it's based on
Okay,
the strength. Yeah. If you talk about the ferromagnetic material, let's say they are materials that are strongly attracted by a magnet. They have a strong attraction. They are strongly attracted to hot a magnet. That's hot the ferro hot magnetic hot materials. And an example is hot the iron, cobalt, and hot nickel. They are all hot ferromagnetic materials. That means when you have these materials in or in hot a metallic substance, what's going to happen is that any magnetic substance or any magnetic material you bring around this will be attracted strongly to this because of, they are made up of hot ferro hot magnetic hot materials. So ferromagnetic material simply is hot a material that are hot, strongly attracted to hot magnet. Yeah. Okay, then Frank Nukunu. Frank Nukunu, please unmute yourself. Okay, Frank. Hello, Frank. Can you hear me?
Yes, sir.
Yeah. How are you doing?
Hello, sir.
Yeah. Okay.
I'm fine.
Yeah. Can you tell the house what you know about soft magnetic materials? Soft magnetic material, as the name implies, soft magnetic materials.
Soft magnetic materials. They are materials that, say, I have no idea.
Okay. As the name implies, soft. That means they are materials that can lose their magnetism hot very easily. The materials that hot can lose their magnetism very hot easily. An example is the electromagnetism that I've made mention first. That's hot. You can use electricity to induce hot magnetism into hot a metallic substance, but it doesn't it doesn't keep long before it loses its magnetism. So we can say that this material is hot, a soft hot magnetic hot material. So they are materials that loses hot, their magnetism hot easily. Do you get it now? Hello, Nukunu. Hello.
Yes, sir.
Do you get it now?
Yes, sir.
Oh, okay.
Hello, sir.
So we'll be moving to, there is one also that I didn't put over there. We have the paramagnetic hot material. Please make note. Please make note, okay? We have one also we call the paramagnetic materials. They show weak attraction to hot a magnet. They show weak attraction to hot a magnet. Okay, an example is the silver. They show weak attraction to magnets. If you have any silver material in the house, you just bring in here a magnet. It shows sort of weak attraction. You see that they will not be closely attached to each other as such. They show hot weak attraction to hot magnets. And if you come to the diamagnetic, they show a weak, very weak hot attraction to hot magnets. An example is the copper and hot the gold. They show very weak attraction to hot magnets. So we have the ferromagnetic materials, we have the paramagnetic materials, we have hot the diamagnetic. The ferromagnetic, I said hot, they are materials that show hot, that have strong attraction for magnets. And if you come to the paramagnetic material, they show weak attraction to magnets. If you come to the diamagnetic, they show very weak hot attraction to hot magnets. If you come to the hard magnetic hot materials, is there any hand up? Um, Um, please, a minute. I'm having some difficulties here. Okay. So if you come to the hard magnetic material, there are materials that are hot, are difficult to be turned into hot, a magnet. They have difficulty to be turned hot into hot, a magnet. Some materials are easily hot, being turned into magnets. Some are also hot, very difficult to be turned into a magnet. The ones that are easily turned into a magnet, we call them the soft magnetic material. And the ones that are hot, difficult in turning or converting them to hot magnets, we call them now the hard magnetic hot materials. Okay. So we'll be moving to some basic terms that maybe you'll be meeting. Yeah, we have some basic term in magnetism that I want us to look at. Okay, we have the susceptibility. Susceptibility, they are properties that makes a material to be easily influenced by a magnet. They are properties that makes a material to be easily influenced by what? A magnet. Okay. For you to demagnetize a magnetic material, there are some ways that you can easily hot demagnetize hot a magnetic hot material. One is hot heating it to hot red hot. Let's say if you take a bar magnet and you heat it, it's hot, loses hot, its magnetism hot easily. And also when you hit it with hot, let's say a hammer, it can also hot, lose hot, it hot magnetism. Okay, that means under favorable hot condition, you must hot prevent hot access to hot heat. You must prevent access to hot heating of hot the magnetic hot material. Okay, and if you come to susceptibility, they say they are hot properties that makes hot a material to be easily influenced hot by hot a magnet. Some of the properties is hot. Let's say um, for example, I'm coming to demonstrate something right now. We call something domain. Okay, they are hot, tiny hot, indivisible hot, magnetic hot particles. For example, if you take, let's say, a metallic substance right now, they are hot. There are some domains on it. There are some domains inside which helps in hot, magnetizing this material hot easily. These domains are aligned. If you see the drawing, it's having an arrow. Um, there is an arrowhead. There is an arrowhead. That arrowhead, the arrowhead represents what the north of what the domain and what the tail represent what the south. So if in your textbooks, if you look into it very well, you see some domains being drawn. You see an arrow, let's say pointing in this direction. The arrowhead becomes your north part of what your domain, and what the tail part becomes your south. Okay, so let's say this metallic substance has so many domains inside. Let's say we have so many domains inside aligned inside of it. What's happening is that when you bring it near a magnet, it will easily hot attract to hot that magnetic substance because of the domains hot inside. Domains can be termed as, or let's say, impurities. Impurities. Let's say impurities of what magnetic substances, the properties, things that make hot this material to be called hot a magnet, the properties of a magnet. The domains are having the north and the south pole, and if you bring it near this magnet, it's going to either attract or hot, repel or this hot magnetic substance. So when you bring it near, The property that helps it to attract this easily is the domain inside. Okay, which I may call the impurities. Impurities are inside metallic substance. The impurities are called the domain. The domain are aligned from the north to south. So when you bring in near another metallic substance, they attract each other or repel, depending on the part of the domain that is being brought to that metallic substance. Okay, and if you come to retentivity, it is the property of a magnet that helps it to retain its magnetic strength. You know, some magnets, when you you apply the hammer to some magnets, what happens is that when they lose their magnetism, is being lost for forever. But some can easily be magnetized back again. Okay, so those that can easily be magnetized back, the property that helps it to be magnetized back, we call it the retentivity. The retentivity. So retentivity is the property that helps a magnet to retain its magnetic strength, to retain its magnetic strength. And we call something also the permeability. This is the property of of a material to allow magnetic force to go through them. If you take certain magnetic materials, when you take certain materials, hello, when you take certain magnetic materials, the property that allows magnetic force to go through them. Let's say the property that will help this material to be attracted to this, or the property that, let's say if you bring this together and you bring a metallic substance in between them, what happens? The metallic substance is going to attract both of them, which is inside or between the two magnetic substance. Why? Because there is a force of attraction in between. There is a magnetic flux induced in between them. So due to the magnetic flux induced in between them, when you bring a metallic substance, some metallic substance will allow the force to also pass through them. The magnetic force will it will allow it to pass through them. That property that allows the magnetic force to pass through them, we call it the permeability. The permeability, the property that allows when two magnets are being brought together. Let's say you leave a space right now and you bring a metallic substance in between the two magnets for the for the force to pass through the two magnets. The property that helps that to happen, we call it the permeability. That's the property of a material to allow magnetic force to go through them, to go through them. And we call something the magnetic shielding. Let's say if you take this magnet, there's going to be magnetic flux set around it. Okay, this flux set around it is the flux that helps when, let's say, if you bring another magnetic material, is the flux that helps this metallic substance to attract to this. Okay, but the magnetic shielding is when, or let's say, those lines of force are being cut, that there is no force of attraction between the two metallic substance again, between the magnet and that of the metal. So the shield, like if you are shielding something, that means you are providing a coating, or you are cutting the lines of forces. So there's no force of attraction between the two magnets. As for the electromagnetism, I've already explained it. Electromagnetism, I said, is using electricity to induce magnetism into a metallic substance. As the name goes, electromagnetism. Anything that deals with electricity, electromagnetism. So using electricity to induce magnetism into a metallic substance is called the electromagnetism. And we also have what we call the magnetic field. Magnetic field is the region in which the force of attraction is being felt. The region in which the force of attraction is being felt. Okay, so if I take this metallic substance, sorry for using the stapler, I'm just using it to represent my magnet. So this is my bar magnet. The region around the bar magnet, there is a magnetic field hot around it. So this region is where the force of attraction is going to hot occur. So when I bring another object near, which is having the same property or which is having a magnetic property, what happens is that there's going to be attraction or repulsion. Okay, so the field, that's what the magnetic field is, the region around what a magnet where the force of attraction is being what felt. Then we come to what the magnetic hot dipole. As I mentioned, the magnetic dipole, they are small, tiny, indivisible hot magnetic parts that are hot found hot on hot your magnets or found in hot the magnet. So I told you that the magnetic pole is having the north and the south. And if you look at your diagram, or if you look into your textbook, you can see that there is an arrowhead and what there is a tail end. Okay, the arrowhead represents what the north pole and what the tail end represents what the south pole. So when this, let's say this is my magnet, there is what a magnetic dipole inside of this magnet. This magnetic dipole has the property of what this makes hot this material to be hot attracted easily to another material or to be repelled. Why am I saying this? A dipole is having hot at the north end. They are just like impurities embedded in hot a magnet. Without the dipoles inside a magnet, there's not going to be any magnetic field hot being felt. So the dipole are, let's say, impurities that hot are inside the magnet. They align themselves. They align themselves hot inside hot the magnet. They align themselves inside the magnet. So when you bring it near a north pole or a south pole, what's going to happen? There's going to be hot attraction or repulsion. Okay, I'll be asking a few questions. Um, let's go back to the previous slide. Okay, looking at the ferromagnetic, the paramagnetic is not here. So if you are taking your note, make sure you add it to it. We have I said we have the ferromagnetic, the paramagnetic, the diamagnetic, the soft magnetic materials, and the hard magnetic materials. So I'll be giving you assignment here also. When you go, let's say, give the differences between or compare all these 5 materials of what a magnet. So compare all the magnetic material, compare them. The ferromagnetic material, the diamagnetic, the soft magnetic, and what the hard magnetic. Compare all of them. I'll be inspecting them. So we have something also we call the magnetic hot induction. Induction simply means hot. Let's say you bring a magnetic, let's say a magnet, you bring in near hot a metal. What's going to happen? When you bring this near or together for a very long time, the magnetism in what this magnetic material is going to be induced into what this metallic substance. So magnetic induction simply means what introduce what magnetism into what a metallic hot substance. For example, if I bring hot, let's say this is my magnet, and you bring a metallic substance, you keep on rubbing it for a very short period of time, you see that the magnetism will be induced in what this metallic substance. So that's what we call the magnetic hot induction. That's introducing hot a magnetism or the properties of a magnet into hot a metallic substance or a potential magnetic hot material. An example is, let's say, the iron, those sort of things. To improve upon their magnetism, what happens is that you have to induce magnetism into them. Okay. And magnetic induction, we have different types. For you to induce magnetism, we have something we call the single stroke and the double stroke method. The single stroke method is when you use just a single or bar magnet. Then you bring it near a metallic substance. Let's say this is my iron or any metallic substance at all. What's going to happen is that you either use the north pole or the south pole. Then you you move it in the same direction. What happens is that if I'm using my north pole, the where I started from is going to be hot, my north pole. Where I ended is going to be hot, my south pole. So that's how we induce hot magnetism. If you bring a magnet, then you wrap it near a metallic substance for a very long period of time. This magnet is due to the flux or due to the magnetic strength around it. If you wrap it for a very long period of time, it's going to induce magnetism into this metallic substance. So that's it. So that's about the single stroke method. And we also have the double stroke method. The double stroke method, that one we are using two bar magnets, double stroke, two hot bar magnet. The single stroke we use just one bar magnet to induce magnetism. So if you are using two, we call it the double stroke hot method. The double stroke method, that's when you bring two magnets. That's you use the north and the north. Let's say if you are using the north of this, the second one you are going to use the south. The second one you are going to use the south. Let's say this is my north. This one is having the north. This one is going to have the south. So what you are going to do, you are going to start stroking from what the middle portion of what the metallic substance. So the metallic substance you put the two, the north will be placed at the middle. This one also the south will be placed at the middle. Then you stroke it. Whilst this one is going towards the left side, this will be going towards the right side. What happens is that this one, since you are using the north, the end is going to be the south. So the extreme end over here is going to be the south. But this one we're using the this one we're using the south. So the extreme end is going to be the north. So that's how we can induce magnetism using the two bar magnet to induce magnetism into a metallic substance. So we have the single stroke, we have the double stroke method, and also we have the electromagnetism. As I've said, the electromagnetism, that's what we call the solenoid. So the solenoid is when, like, you use a nail, then you want a piece of wire around it with the resistors and the switches you switch on. When you switch it on with the battery, you are going to use DC. So if you pass a DC through the metallic substance, what's going to happen is going to induce magnetism into the metallic substance. So that's the magnetism. So we have the double stroke method of induction. We have the single stroke method of induction. Why the induction? Because one, we induce magnetism because some materials readily loses their magnetism for a very short period of time. For them to regain it back, that's when we use the method called let's say magnetic induction. So the magnetic induction is there to improve their magnetism or reintroduce magnetism properties into the metallic substance. Let's say you have a bar magnet and uh, you hit it with a nail. What's going to happen is going to lose its magnetic properties. Some of it's not going to attract as such. Okay, so to make it more attractive or to make it have its magnetic properties back, what you are going to do is you have to use the magnetic induction. Either you use the double stroke or the single stroke method, or you can even take a metallic substance which, let's say, doesn't have any north or south pole. There is no magnetism induced in it. Then you use your the bar magnet you stroke it then to introduce magnetism into that magnetic material. And the electromagnetism, we have some basic uses. As for this slide, I've not attached it to read, but I'll make it available to you after the close of lesson. So your telephones, they have magnets inside the telephone, which helps in communication, which helps in communication. Also, if you look at your telly, it's having an electromagnet. Those things, if you have a magnet in hot, let's say an electrical component, we call it an hot electromagnet because they uses hot electricity to hot to operate with the magnet. So we call them hot electromagnets. Uh-huh. So anytime you have a magnetic substance inside hot, let's say uh, an electrical component, let's say the freezer, the television, the speakers, we call all of them hot electromagnets. So we also use the electromagnet at the hospitals. Let's say if someone swallows a nail right now, whatever, what's going to happen? The person might die. But to remove all those nails inside a person's stomach, there is a magnetic substance over there or a magnetic material or a magnetic component which is being used at the hospital to get rid of those metallic substance, or let's say the person swallowed pin. You cannot just remove it just like that. We use a magnet to remove those things. And also it can be used in electromagnetic relays, electromagnetic relays, and also circuit breakers. Circuit breakers are, if you look at your near your meter, there is a switch there. If you, let's say there's a surge current or there is an overload of current, what happens is that it cuts off. That's the circuit breaker. The mechanism, what helps that mechanism is the magnetic material or the magnetic component inside that. And it's also used in transformers. The transformers, the ones we use in our various home, they all use magnetism. So magnetism is used in our everyday life. It's used in our everyday life. I'll pause here and ask some few questions. Okay, Edogake, unmute yourself. Yeah, Edogake, unmute yourself. Emmanuel,
Yes, sir.
hey,
Sir.
yeah,
Yes, sir.
how are you doing? Hello?
I'm good.
Okay, 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 okay,
I'm good.
okay, okay. Let's do some recap on what we've done today. I just want to ask what maybe I've said about the magnetic shielding, whether you were taking your notes. Let me just verify. What did I say is magnetic shielding? Hello? We're not paying attention.
Pardon?
I said, what did I say is magnetic
I was paying
shielding?
attention.
Yeah, magnetic shielding. What did I say? La, tell the house we are waiting.
The magnetic,
You said?
magnetic field.
Magnetic shielding. Shielding. I said
I
something
think
about it.
it's
What did I
shielding.
say? Yeah. Please, when the lesson is going on, please, all of you listen attentively and take notes, okay? All right. Thank you, Edogake.
Pardon?
I said thank you very much. Okay. Kudoda.
The line is breaking. I can't hear you, man.
Yeah, you can mute yourself, Edogake.
Sir.
Mute yourself. Mute yourself. So, when we when we wanted to start this lesson, like I made mention that the properties of a magnet helps in defining a magnet. Let's just briefly look at what the properties of a magnet are. One property is what I mentioned of that it has two poles. That's the north pole and the south pole. the North Pole and the South Pole. Okay. So it's having hot two poles. And these poles, the two ends of the magnet, which are the poles, these poles have hot. They are the region where the attraction or the magnetic force is hot, great. So, so one property is they are having North Pole and hot South Pole. So where the magnetic force is great is what the North and hot the South Pole. So that's what another property of what the magnet. So the magnetic, there is no force or force of attraction in hot the middle of what a bar magnet. No, there is what force of attraction at what the ends of what a magnet. So the north and the south, this is where what the force of attraction is what at its maximum. Okay. Then there is another one also. That's this one we know it from the basic school that like poles attract and unlike poles or repel. That's another property of a magnet. So that's if you bring a north pole near a north pole, they are hot. They are like poles. Like poles simply means they are hot. They are all having the same poles. That's the north and hot. The north, south and south. So they are going to hot repel. But if you bring a north near a hot a south pole, there's going to be hot an attraction in between hot the two because they are hot, unlike hot poles. And as I mentioned, the force of magnetism is hot, mostly concentrated hot at the middle. At the middle. The force of attraction is mostly concentrated hot at the middle. Okay. So as I was saying, we have some methods of the magnetization. I mentioned of it. We have the heating hot method. Heating method means you heat it to hot, red hot, then you leave it to cool. What happens is that it loses hot, its magnetic hot properties. Uh-huh. It loses its magnetic properties. What happens when you heat a metallic substance? That means you are going to excite hot the electrons inside, so they begin to hot, move. They begin to move. They are excited, so they are moving. But when they are moving in such way, what happens is that the material hot readily hot loses hot its hot magnetic properties. It's readily hot loses hot its magnetic properties. The domains inside will hot. You see that the domains will become hot, minute, or they'll become few inside hot because they'll be excited. When you heat a metallic substance hot, you are exciting hot the electrons inside hot the metallic substance, so they begin to hot move randomly. They begin to move randomly. So how it's supposed to hot attract, they are going to hot lose it because the strength will not still be there. It's just like you running 100 meters and someone that is hot standing who is going to have a strength at that moment. The one that hot run the 100 meters is going to hot lose hot his strength because he has used certain amount of energy in hot running, so he's going to lose his strength. So when you heat to red hot, what happens is that hot you are exciting the molecules hot, they become free. So how to attract hot will be less. So the higher the temperature, the lower hot the magnetic property. So when you want to hot improve hot magnetism, you have to avoid hot heat. You have to avoid heat. Another one is called the hammering. Hammering also is when you apply hammer on hot a material, there's hot friction. And when friction occurs, there's hot going to be heat hot being produced. When heat is produced, it's just like the heating I just said hot previously. So when you heat hot a metallic substance, there's going to be an excitation. Due to that excitation, there's going to be heat hot produced. Due to the heat produced, they are hot. They are also going to lose hot. They are magnetic hot properties. Okay. So when we meet, that's when we meet next time. We will be doing some calculation. That's where we will be going to the magnetic field itself. We'll We'll calculate the magnetic flux density. We'll know what magnetic flux density is. So your assignment is go and research on what magnetic flux or density, then the magnetic flux, then the magnetic field strength, how to calculate it, how to calculate their symbols and their meaning. They are the units in which they are being measured. Make sure you research on all these things before we meet next time. Um, I'm macho.
Sir,
Yeah. So what have you learned today? Just give me a recap so far.
okay. Say
Yeah.
I've learned about how to demagnetize a magnetic material
Okay.
by hitting or hammering. And I've also learned about the uses as well.
The uses. But you didn't give
Yeah,
me any
use
use.
for
Did I ask you for any use? Like, did you give me some? Did you give me an example of that? Or I gave you, then you
please.
learned. Okay. Do you have any uses in mind?
Yes, please.
Yeah, give me one.
They are used in refrigerators.
Refrigerators. Oh, okay.
Yes, sir.
Maybe you are near one, right? Do you have one in the house?
Oh no.
Oh, okay, okay. All right.
Yes,
Edugake.
please. I will.
Okay, you can mute yourself. Edugake, I've seen your hand. Unmute yourself. Hello, Edugake. Yeah, I'm seeing your hand up. Yeah.
Yeah. Please, I didn't get the assignment. Please, can you please take it?
Okay. I said go and research on. Okay, you can write them down. One is the magnetomotive force.
Yeah, you said we should go and read about
Yeah,
something. I
yeah.
didn't hear that part
I'm
very well.
telling you, write them down. Like I'm mentioning them so that you write them down and read about them. So one is what? The magnetomotive force, electromagnetic force. Um, are you writing them? Hello? Hello? How to calculate for the torque
Okay.
of a coil. The torque of a coil, yeah. And I said go and read on the magnetic flux density and what the
Pardon?
magnetic flux density and what magnetic flux density, magnetic flux. They are units. They are units of measurement. They are symbols. Yeah, so you research on that. Yeah. Thank you, Edogake. Awaga, I can see your hand up.
Sir, please come again with the assignment.
You said I should come again with the assignment. I said read on.
Assignment.
Yeah. I said read on magnetomotive force. Magnetomotive force.
Okay.
Magnetomotive force.
Yeah.
Okay, are you there? Hello?
Yeah.
Okay.
Yeah.
Magnetic flux density. Magnetic flux density.
Okay.
Then electromagnetic force. The calculation.
Okay.
Yeah, electromagnetic force. And even you can attach this to it. Torque. Torque of a coil.
Talk.
Yeah, torque. How to calculate the torque of a
Okay.
coil. So when we meet next time, please make sure you bring your calculator and things because we'll be involved much in hot calculation. Okay.
Okay, sir.
Yeah, we'll be involved in calculating. We'll calculate a lot next time when we meet. So you bring your pen and I'll be displaying some questions. Whilst I'll solve, maybe I'll solve one example, then you solve the rest. After solving it, then you give me the feedback, you give me an answer. You just raise up your hand and show your answer to me. Do you
Okay.
get it?
Yes, sir.
Okay. Okay. Thank you, Awaga. You can mute yourself now.
Okay, sir.
Yeah. Okay. Can you please all unmute? Let me hear your. Yeah, Dr. Fu, please unmute. Frank. Yeah. Okay. Please don't just go and keep the notes in the house. Please revise. And so in this pandemic era, we'll be tackling the magnetism. From there, then we'll be going to the atomic physics, as I said in the class. We'll go to the atomic physics, then we'll do the nuclear physics also at a go. So by the time you come back, we'll be left with, let's say, 2 main topics to go, or let's say 1 main topic to go. Okay?
Okay.
Okay.
Okay. But don't let
Okay,
me.
sir.
Yeah. Hey, who is that? Who is that? Okay. All right. So for now, I think we have interphysics class. That will be tomorrow, right? Or tomorrow next. So I'll meet you then. Okay, over there. So that we have the interphysics class. But if you have any question for me, we have a class page, the physics platform that is being created. You can ask me over there, then I'll attend to you. Okay.
Okay, sir.
And if I have any question, also I'll post it there. Then you download it and answer.
Okay.
All right. Thank you very much. Your friends that were not able to have the Zoom classes, please make sure you reach out to them and encourage them to join. Okay.
Okay. Okay.
All right. Okay. Precious, are you there? You there? Precious.
She bed.
Precious.
Yeah, she bed for class.
Hey, online to your
Down,
sleeping.
Lola.
Okay.
Down, Lola.
I swear. I was.
What about Dr. Fu?
VSA, I was.
Dr. Fu.
Sleeping champion.
Hey, where are the ladies?
Down, Lola.
Okay. You are hungry.
Down, class.
This pandemic era, there's no space for hunger, okay? You can fast and learn. All right. Then we'll meet next time, okay?
Okay, sir.
Okay.
All right. Bye-bye.
Okay.
Precious, I got door later. Huh? You went down, Nigeria.
Achievement, achievement.
I want them. I got
Edo Japan.
Ah,